In this video I will show you basically the main feature of the Kobeltstuff Save System framework. That would be the fact that you can refactor everything in your project at any time and don't have to be worried about losing save data. You are able to migrate an old save file to a new save file at any moment, at any time. You are in full control what is happened to the data. So to demonstrate or to show you how it's done, we are using our custom iSave data we are created earlier. So let's imagine that this class is live in a build, players have save files with it, and you want to change something. Like, for example, let's change the vector 2. We decide we need a vector 3. So, you see, there is nothing special to worry about here now. We just simply change 2 to 3. And to migrate that, we need our lovely iSave data generator. So, we open it up, getting our inventory, load the type. We know we don't need display name. We have now a vector 3, and we generate a code like the first time. The copy constructor didn't change. The writer did change quite a lot. So we are putting it over the previous one, since we don't need to be able to write an old file version. We just want to read it later. So, and you see the code generator auto-increments the version, and we are now writing 3 bytes for the vector 3. We are using the case. Since we are in version 2, we don't have the whole read bytes, only the case for the version 2. So we are using that. And we have the new reader. We are copying it in, and you see reader bytes for 2. We are now reading a vector 3 instead of a vector 2. So basically we are done, but we have to handle the old reader, since the player could start the game and with a new build, and the files can have version 1. In that case, read bytes would be called, the version 1 would be called, and now we are here. And in the old reader we see grid size is new vector 2. That isn't correct anymore. We can just do vector 3, and so you can see it a little better. Use the read byte single that wants the read byte single of the vector 2, and complete the vector 3 with our custom default value like 0. So now we are getting a grid size new vector 3 out of the version 1 reader. Note, we have to consume the binary reader, so we are in the correct order of the read. And that's all there is to change a field. If we are adding a field, that's only important in the writer, and in the new version we could do in the old version setting here a default value. If you want to delete a field completely, just delete it. Delete it out of the copy constructor. You see the new reader don't need this field anymore, and the writer don't need the field. It's now the version 1, the previous version needs this line, the read int, but we don't have the field. Then we just consume it and let the garbage collector take care of it. And that's a refactor in a data structure. Now we have a secondary migration layer, name change of a class like inventory. Let's change it to player inventory. So no, quiet. So now we are renamed our class. The old qualified name stays as it is, this inventory. And we need the old qualifier name for that, qualified assembly name, and we need the new assembly name. So and we to migrate a name change or assembly name change or anything that's had to do with the assembly qualified name, we need to open up the project setups and change the current save version. It's done that it's by 1 and just increment it and save it. So the save system knows the version is different. I need to use the migration hook. The migration hook you can find under runtime manager migration hook tool, migration tools, and there it is. This file you need to change to be able to migrate your data successfully. And the important part is here. I have prepared it. As you see, you have a dictionary, string. The key is the old assembly qualified name, and the value is the new assembly qualified name. This entry is for an example in the Save framework, and this entry I did added for this video. You see we have inventory, old assembly qualified name, and the player inventory. So basically what's happened is, if the version in this project setups is different than the version in the file, the migration handle migration method is called and simply switched the qualified names around, the old to the new one. So before the load method of the save system tries to resolve the data. So the type factory knows, this is a new qualified name and I use this. This is all there is to it. You have the same dictionary for the subkeys, because since subkeys are not directly linked to the file system, you could use subkey as an assembly qualified name of your mono behavior as a subkey, and then you're able to migrate that too. So basically this is all that's needed for a proper migration, and you see this is simple, not that big of a problem. Just consume the old reader and you are done. You basically can delete this whole class and create a new class, and all you have to get your hands on is the old readers. So you can consume the old save data with the old readers and map it to the new class. It's basically no problem. There's all there is to it for an iSave data. And then mono behavior and iSave handler migrates similar, like with it samples our player we are created earlier. You would do changes on these fields, also basically any changes to fields or structure that involves this. You are using the generator and regenerate all that stuff, like the iSave data. So for example, we are deleting display name. We don't need display name in a save me method. We have load me. We would have case 2. We do it manually and load me v2. We copy this and this. Load me v2. Don't need a display name. Basically, here we are also need alt display name. Edit node, please increment the save version so no errors occur. We also have to consume, because we are auto increment the index. Or you just could, this would be better for readability, but you can easily just do this, increment the index, so you are ignoring the part of the index, but then you lost the reason why, and of that way you are able to tell after months that why he did this, because there was a display name never used again. Basically the same style as iSave data, and the assembly qualified name of this mono behavior is only interesting if you are using it as a subkey, which is a valid point. That way you have to use the migration handler for the subkey if you are doing this. But anyway, at any other moment, the mono behavior don't need to regenerate an assembly qualified name, because that's never called in the save system. Only the fields had to identify themselves with an assembly qualified name, basically. Yeah, that's all there is to the migration, and in this way you are able to change anything at any time. You have the full control of your data. And with the generators, the work ended up quite easily. Yeah. The next video I will show you the samples, give you a quick overlook, and then you can decide if the Save framework is the framework for your project or it isn't.